Welcome to Fibotech. As always, I'm Nick. Today, we're going to talk about everything that's on this table, including the lathe itself. So this is my haul from a local swap meet, buy swap and meet sort of thing. The biggest in my town sort of happens once a year. A lot of stuff happens there. And today's video is about to show you what you can get if you're willing to dig in those sorts of places. There is still bargains to be had in these sorts of places. It's not just all, consumer stuff or anything like that. You can still find good quality things as long as you're willing to look for stuff in every box and every trove across the whole thing. That does mean that, the swap meet in my case lasted 3 days. We went on the last, me and the person who could drive, went on the last day to get everything that we see here today. So to start off with, I'm just going to start through and tell you the prices of things and why I bought them, etc. So we'll leave the lathe till last because there's a lot to talk about with that. So the first little thing I got was this little bench vise, or corner vise I believe is the technical term for it. That was only $5, as is quite obvious by the signage on it. This will actually go into this shed, so I have to keep going next door every time I want to use a vise. So that's it. I've also got to make a jaw up for it. It is missing a set of jaws, which will involve probably either making or finding myself some screws that fit all those little holes. So yeah, there's a bit of stuff to involve with that as a whole. Otherwise, it's in good condition, and it will definitely serve me well. So on to the next things. There's this little pile of chucks, key chucks. So again, just what you'd see on the end of a drill, but in this pile, they're all Jacobs chucks, either made in England or Japan, except for the black one I just showed you, which is a Yukai or something like that. I'm going to have trouble pronouncing names because, I'm human. This one's also made in Japan, so they're all Japanese-made chucks of various eras. They're all pretty nice, but after, soaking them in a literal gallon of petrol and a mixture of petrol and kerosene to get rid of all the grime and grit and a bit of rust on them. This was found at the bottom of the box. This is actually a chuck, a Jacobs chuck, which I don't know if you or anyone can actually read, but it is actually legitimately a Jacobs chuck that is made in England, and it is a number 1A. Now, why am I showing this one in particular? Well, it's because of how those teeth mesh. Yeah, that is a true 0mm engagement. I can literally hold a 0.1mm drill bit with this, which is kind of cool. And it works fine. I don't necessarily have quite the correct key for the chuck, but that's fine. It also is a tapered fit. There's no threads in the back of this. It's just purely a cylindrical hole. Which can cause a few. It's going to be interesting to try to find something to do with it. I may have to use a lathe to make up an adapter bar, so therefore I can use it in drills and other things. All the other chucks are pretty, bog standard. Particularly this one. This one's actually off a drill. This one's actually off a drill. But otherwise, most of them are lightly wallowed out. But they're all very useful. I will plan to use them. But yeah, all five of these chucks plus the key, which is nice, were $7. So, hey, if all I had to do was use a bit of kerosene, a bit of petrol, and some chainsaw oil to get them up and running, I'm not going to complain with that. So, let's move these out of the way and talk about the two taps I bought. Okay, it may sound pretty simple, a tap's a tap. These are nice, again, British made, UK made, by Goliath. So, a nice high quality taps. One is 5/16 BSW intermediate, high speed steel, so nothing fancy. Although why I did buy this one is it matches the cornucopia of threaded rod that I have in the same thread. Obviously not this bit, but I have like 2 of these lengths. So that's why I bought that, so I can make up my own nuts and long nuts and threaded assemblies I can thread onto that. It'll also help me with the drill press project, which I mentioned mid or late through that project. The modification to be done was to make it so therefore there was a handle on top to be able to adjust that much easier instead of getting our Allen keys, twisting the Allen key, and doing a whole bunch of stuff. So that's one tap I got. Now each of these taps was $3 a piece, which is, considering these taps typically go. Sorry about that. That's a rat or a cat moving around. I'll be back once the dog's settled. Alright, sorry about that disturbance. The dog's going nuts, it's fine. Anyway, back onto the second tap I bought. Again, each of these was $3, pretty standard thoroughfare. But again, about third of normal price. Typically on eBay, that other tap will go for between $5 to $6 to $9, especially if you want to get the same brand. The other tap I got was an M12 Fine, or M12 by 1.25 in pitch. The reason I got this one is this lathe has, I'm going to have to modify this to make it into a metal lathe, because right now it's obviously a wood lathe. And this will be handy for threading assemblies down onto this bed, which I'll get into more when we talk about the lathe. So the thing is, when you want to go, now M12 by 1.25 is typically used by Japanese manufacturers as wheel nuts, so it's not an uncommon thread, which is good. The other thing about this is that it's a very fine pitch. So it's a metric thread, but it's a finer pitch than what you'd normally see in M12. M12 is typically M12 by 1.75 millimeters. So peak to peak of each. So first, that second number, M12 is metric 12 millimeters final diameter. So if I grabbed a pair of verniers and measured the diameter of that from one side to the other, it would be 12 millimeters. The 1.25 or 1.75 I'm talking about is actually from the peak of one tooth to the peak of the next tooth. Okay? So M12 by 1.25 is considered metric fine. Metric coarse would be M12 by 1.75. Now, why did I pick the fine thread? Somebody may be asking. Because yes, the bolts are more expensive, etc., etc. The reason is I haven't got exactly the most amount of thickness here to actually get a nice tight fixing on. So using a finer thread, I have more threads in the same thickness of the material. I'll give you some math and some example. If I was to have a 3mm thick piece of metal I wish to tap into, if I was to use metric coarse, 1.75mm peak to peak of each thread, then I'd only get about 2 full threads through that material. However, with the 1.25, I gain an extra thread. So I get 3 to actually closer to 4 full threads of that material. Which means the bolt's actually going to hold better. You can torsion it, you can actually put a higher torque on there, and a whole bunch of other things just nicer with it. Now, of course, here I have close to almost half an inch. Now, again, does that really make a difference? Not really, but what it does give me is the ability to actually provide torque, a more consistent torque, as well as it actually will generally hold better as well. So, one thing to think about. Okay. On to the next bit before we talk about what the rest of the video is going to be about. This is a lathe chuck, as is pretty obvious. Pretty standard chuck. Now, this was the single most expensive item out of the whole shebang. As in, it totals more than everything else I just showed you because this was $30 by itself. Now, why am I willing to spend so much on a chuck? Well, A, it's an English-made chuck from probably about the 60s, going by the age of the thing. It is from the Crushman's Chuck Co. in Hartford, the UK. So it's a nice chuck for starters. No, it didn't come with a key, but that doesn't stop me making one out of all the weird bar stock and everything else I have lying around. Yeah. Anyway, so this is a little 3-ish inch chuck. It is non-reversible, which is fine. It's got more than enough trouble for what I need. The only issue is it doesn't come with the adapter plate, which is where this bit of wood that's already on the wood lathe will come in handy. I'll explain that in a bit. So that was $30. It works quite well, although right now I have to use a screwdriver to adjust the size of it until I make myself up a chuck key, which will be in its own time. So this will get mounted onto here eventually when I get this thing set up, which I'll get into more about this in a second. So, the obvious thing on the table that probably most people saw on the thumbnail is a wood lathe. Now, most people ask, how cheap did I get this? Well, it started off at $20, which was very tempting. Then I said that to the guy who was selling it, and he said, I'll make it even more tempting. I'll knock it down to 15 for you. And at that price, the motor is worth more than $15. So, yeah, I walked away with it for 15 bucks. It does work, however, it doesn't currently have a belt, because that was beyond, resability. It was already falling apart, it's gone sticky, all the rubber's broken down it. So we'll have to find a belt for it, which won't be too hard as a standard belt. But beyond that, I have to do a lot of other work on it. As you may notice, the cable on it is replaced. Originally, the cable, not kidding here, that's the cable that came on it. 2 single insulated cables with a plug from probably about the mid-century, about 1950. So, yeah. That got taken off pretty quickly. Also, as you may notice, it was only 2 cores. In Australia, every motor or everything requires an earth for safety. Well, that had to be added. So, I'm going to bring the camera in, and we can have a bit more of a closer look at this wood lathe, and go over all the little bits that need to be done on it, / what I've already done on it, and not shown you, because of, well, I don't want to teach people how to kill themselves. So now we're nice and close up, we can now have a better look at what's sort of happening. So yes, it did come with the tool rest, which is something I don't plan to use, primarily because I'm not going to use this as a wood lathe. This will actually be converted to a metal lathe. So, once I get this off, sorry, I should have prepped this. Come off. So, as you can see right now, it is just a standard everyday wood lathe, right? You know, spinning bit, motor, etc. Now this motor is quite big. It's a third of a horsepower, third of a mechanical horsepower, which is a bit bigger than I was expecting to be having on a lathe, but it's nice, it's torquey, it's good. So what I've done with this motor already, and not shown it on video because, yes, I have the skills to do this because I've actually gone and done a certificate 2 in electrotechnology, is to actually rewire this motor. As I said previously, wherever I actually chucked that thing, this is the wiring that came on this motor when I bought it. This is totally not up to spec. If you see a motor like this being in use, run away from it quickly because this is very unsafe. It's not double insulated, which means that these are just single cores, bits of copper with a bit of insulation over them. You're required, pretty much everything around the world nowadays is required to be double insulated. Pretty much everything has to be double insulated these days, so you can't really get away with single insulated cables like this unless you're dealing with DC and below 90 volts. But so that's where that comes into place. That's the first thing I had to fix. The second thing is there's only 2 cores here. There's only an active and neutral in the old colours. There's no earth, which I need to add anyway. So what I ended up doing was I ended up using some extension lead that got cut in half by an axe. And I know that is actually true. We were cutting up wood and managed to cut an extension lead in half, thankfully if it wasn't live at the time. So a bit of that got used to make up a new lead for it, and also bring out an earth and crimp an earth and make it actually earthed. So hence this has actually been electrically tested. So I've done so if there's wondering what tests I've done on this, if there's any electricians watching, I've done my active to neutral resistance to make sure there's a circuit here. I've tested insulation resistance between each of the phases to earth. I've also tested to make sure that live to earth is not, to make sure the casing is not live. I have actually had it running and then used my multimeter, which is rated up to Cat3 at 600 volts, to actually test to make sure there's no conductiveness to earth, to make sure that the shell itself is not live. So yes, I've done all that. So I've done my resistance test, I've done my insulation resistance testing, I've done my conductive testing, I've done all that sort of stuff. My polarity testing on the cable as well. And I've also added a cable grommet for the earth to come out here. This will become the earth star for the whole system, because this bed will also be earthed eventually as well. Anyway, so enough about that. No, I'm not going to show it on video, because I didn't even film it, because I didn't want to show it on video. Okay? So anyway, so this little wood lathe is actually not bad otherwise. The bed is actually in pretty good condition. I will have to take a wire brush to it and polish the ever-living crap out of it. But in general, it's not a bad Gerber, not a bad device in general. It does have a through hole, which is good, which is nice to see. You can see that somebody's already been doing a bit of work on this. This is actually already concentric, so I don't have to worry about recentering this. And as I was talking about before, my plan is to take this bit of wood, I'll chop off this bit here, which is doing nothing, and I'll resize this up, take it down with the files and chisels and stuff I've got, and make it so it fits on that. So essentially it will sit that way. Okay, so it's going to sit back here, but it's going to sit concentric. So I'm going to take this diameter down until it perfectly meets the little lip that's inside this. So you can see the little lip in here. This bit of wood will actually sit in that, and then I'll screw it in place with the 3 screws to make sure it's all nice, mechanically, properly attached. So that's what that is. Now most people will ask, how the hell am I going to turn this into a metal lathe? That's the plan at this stage, is to turn this into a metal lathe. Well, it's already got a nice bearing block, it's already got the motor, it's got a belt to make that all work. And it has a nice flat square bed. Now, the thing you have to think about is a wood lathe is only really meant for manual work, i.e. that's why it has a tool rest and nothing else. I have to make up my own way. Way or key, as I believe they're called, is essentially what everything rides on. Your tailstock rides on this end and comes this way, and then you have your actual, things you hold on to, which you normally see on a metal lathe. Now, that's going to be achieved by this rather large and heavy piece of steel. So what I'm going to do is I'm going to cut this off square, which I don't know you can see that. But I'm going to cut this off square, and what this will do is, with my M12 tap pad board, I'll be drilling through this and tapping into the base of the lathe, the actual bed of the lathe, and tapping down onto this. So this will become the new working surface. What that will allow me to do is I'll actually be able to then clamp, I'll actually then be able to make runs on this thing to be able to make things go left and right and back and forth and everything else. That does mean, however, I do need to work out my my spindle, all my handles and the way I'm going to do things. That's projects over many next couple of probably months at this stage. First of all, I have to properly mount this thing to something, because right now it's just held down by wooden blocks onto a piece of chipboard. I think it's actually MDF, sorry. So a bit of MDF. The motor is mounted onto a piece of wood. So there's a lot of work to be done on this thing, but it's going to save me a lot of time. I was planning to make my own lathe anyway. This is why this bit of steel's here anyway. However, this saves me, $15 saves me probably close to $300 in other materials and other ways of doing things. So that's just that, I suppose, is the best way of putting it. It's going to save me a lot of time. There's a lot of work still in this device, but it is going to save me some time. Anyway, so let's go back to the wide view and we'll wrap this video up. So that's what I got from Swap Meet. So in total, close to $70 worth spent. But out of that, I got a lathe, a chuck, a whole bunch of other chucks, taps, vices, etc. So over the next coming weeks, as I'm publishing videos on Mondays these days, you'll see these things being used. So the first ones we're going to be getting this vice up and running, and actually in this end of the shop being used, and then I'll start working on the chucks or other things before we start working on this lathe too. So this gives me projects to show everyone who's watching about how I'm building my own metal shop, in general terms. So a bit of a time for an outro, I suppose. So you will also be seeing videos on Mondays. That's my release date now. I'm trying to actually keep to that this time around, not like it last time. Anyway, so 1 video a week is my schedule at this point in time. If you do want to support the channel, I do have a PayPal donation link in the description below if you wish to. I'm not going to force anyone to do it. Just it's there if people like seeing what I'm doing and want to contribute to what I'm doing. So anyway, thank you for watching. Like, subscribe, we'll do all the usual shenanigans. Anyway, I'm Nick from Firebird Tech, and thank you always for watching.